I could have, in the original program, I could have just said a line dot start dot x gets a value of 23, and then use one more line and say a line dot start dot y gets a value of 79. I could have done that instead of invoking the subroutine and have the subroutine to actually do the initialization. Is that okay so far? Are you guys understanding the alternative to what I just did in the previous program? Okay? So here's the question. Why am I doing it, why do I use the other program? Let me just bring up the other program first so that we can see the two programs side by side. And then we can say, what is the value of the first version of the program? Why do we want to do it in a very cumbersome way when there's a quicker and more direct way of doing things? Okay, so these are the two programs. And I just want to scroll everything so they are aligned correctly, like that. Okay. Everything up to line 18 are exactly the same, except in the second program, I access the endpoint of a line directly and say that its x value is 200, and then I can have another one to initialize the y value of the same point. Whereas in the first program, I invoke a particular subroutine called init coord xy and go through all this trouble passing parameters, going into a subroutine, and have the subroutine to do effectively the same thing. So why do I want to do something like that? I mean, from the efficiency perspective, the first program, which is the one on the right-hand side, is less efficient. If you just look at the trace, the length of the trace, it's longer. Okay? All the allocation of columns, all the deallocation of columns, they all take up not just memory resources, but also take up execution time. So that means, apparently I'm wasting time doing something that could have been done a whole lot more directly and also more efficiently. Okay, so we have a kind of question here, why are we doing things that way, which is a better way, than, rather than doing it in a more direct way? That's the question. So to answer the question, I have one analogy, and I think most people cannot forget that analogy. What does a TV look like about 10 years ago?
Big boxes.
They're big boxes. They're basically CRTs. Cathode Ray Tubes. Okay. So let's talk about cathode ray tubes a little bit, because I want to make sure everybody understands the point of this stuff here. So apparently we are switching to a topic that has absolutely nothing to do with programming, but it does have everything to do with what we are talking about here. A cathode ray tube, if you look at the side view, looks like this. And this is basically a vacuum tube. The entire TV, or the bulk of the TV, is one huge vacuum tube. So you can imagine the thickness of the glass to kind of keep the vacuum in the inside without crushing. And what happens is they have a filament here that is heated. And then they have a gate of some kind that is charged. And then they have bagel magnetic coils on both sides. What happens is the filament will get heated up. Okay, so basically it will be heated up to start to glow. And when that happens, electrons can be emitted from the cathode. This is called the cathode because it has a huge negative charge to it. So the electrons will be they're eager to get out of the electrode, especially when you have a gate like this, which has a huge positive voltage to attract the electron and say, oh, come on out. Okay, so the electron will come out. Okay, so E is represents electron. It will come out, and depending on the plate charge and also depending on the coils, you can deflect it. You can basically make it go in different directions. You can speed it up to go faster. You can slow it down to go slower. The deflection will basically say this particular flow of electron will go to this pixel on the screen. So you can control which pixel gets the focus of the electrons. You can also change the speed, which means it will be brighter. You can change it to be dimmer by changing the velocity of the electron. Okay, and that's how you can have one single point and just sweep it, horizontally and then vertically to create an image on the screen. Okay, so the mechanism or the physics behind it is kind of like this. So that means, if you want to increase the overall contrast or the brightness of the image, you have to crank up the voltages to increase the brightness. If you want to decrease the brightness, you decrease the voltages. Let me ask you this. How many people have to open up the case of a TV like this and adjust the voltages in order to adjust the picture quality? No one. Okay. What do you do? What do you do to change the contrast of a TV or the brightness of a TV about 10 years ago?
Press the button. Press the button.
Well, you have an OSD, right? You have the on-screen, display. So you just, click your TV, goes into the menu mode, and then you go all the way down to picture quality or picture properties or whatever you want to call that. And then you scroll, it has contrast control, brightness control, color control, tint control, that sort of stuff. You just go to the right tab, and then you press the cursor keys to increase or decrease that particular value, and you're done, right? Okay. Now, what about LCDs? LCDs work in a different way. So LCDs, start with a backlight. Okay. In the good old days, we use cathode ray tube. We use fluorescent tubes as the backlight. These days, we use LED, which makes it more energy efficient. But nonetheless, you have a light source behind everything. The light source will go through a polarizer first. Polarizer, which basically means if you have light wave going out like this and light wave going out like this, only one will go through the polarizer. After the polarizer, you have the liquid crystal layer, and if I just want to make a liquid crystal layer, easy to understand, it basically has two electrodes. Okay, it has two plates that are conductive. If there's no charge between these two, then the liquid crystals inside will just be kind of random. Okay, there's no particular alignment direction, and light will be able to go through. Okay, so if there's no charge, light or a little bit of light can go through. On the other hand, if I use a particular charge across this here, the liquid crystal in the inside will all align in a particular direction, which will basically block the polarized light that is going past the polarizer, and therefore this pixel will look basically dark. It will be quote unquote off. Okay, whereas the other pixel will be on because light can get through. The bad thing about LCD display, which includes all the LCD displays that we have today, is that only about 1/10 of the light of the original source can go through, even when you look at one pixel that is at 100% brightness. And that's why it is so inefficient. Okay, if you want a white pixel, to be as bright as possible, the brightest it can get is only 10% of the backlight behind that pixel. Okay, so that means on your laptop computer, most of the energy is wasted because of the 90% cutoff of your LCD screen. Okay, to increase the contrast, to increase the contrast or to increase the brightness, you decrease the voltage across the plates here, so that these crystal structures are not as aligned, and it will let more light through. So what was the last time you have to tweak the voltages across these two plates of a liquid crystal display TV? Never, right? So how do you change the brightness of an LCD TV? The same way you did with a CRT TV. With a remote control. And not only with a remote control. The OSD of your remote control, has it ever mentioned the high voltage coils or the high voltage plates of a CRT? No. Has it ever mentioned about the bias voltage, on an LCD display? No. In either case, it is called what? Brightness. Okay? And you can only increase the brightness. Sorry?
Sometimes it has a plus or a minus on one side or the other.
Yep. Yeah, but nonetheless, they're still called brightness. And you can perceive that we can have a quote-unquote universal remote control that will work with the good old CRT type of TV, the LCD TV, plasma TV, and when OLED, organic LED, becomes reality, will also be able to control all that. And from your perspective as a consumer, you don't have to learn anything new at all. They work exactly the same way. They have a power button to turn on and turn off the TV. There's a channel change button. Now, when you look at the channel change button, does your TV change all that much, depending on whether we are using the good old, analog, broadcast versus the new digital broadcast? No. Channel up is channel up, channel down is channel down. You don't see any differences, right? So that means your remote control is doing a really good job of what we call abstraction. Okay? What does abstraction mean? Abstraction means hiding details. Okay? Hiding stuff that you don't need to know. Okay? Your remote control is doing a really good job with hiding details because you don't need to know the physics of the display device that you're using. You don't need to know how the signal of TV stations are broadcasted to your TV. You don't need to know any of that stuff. All you need to know from a consumer's perspective is stuff that you need to understand. I want to watch channel 3. Channel 3, click, go. Okay? And guess what? Channel 3 today is not actually channel 3 in terms of the digital broadcast channel. Okay, so basically your remote control or your TV is actually doing all the remapping for you. So channel 3.1 goes to the first sub-channel of channel 3 in the digital broadcast. Channel 3.2 goes to the second sub-channel, and so on and so forth. But when you look at the actual channel number, which is determined by the frequency, they're not channel 3. Okay, so everything is abstracted, but as far as you are concerned, your remote control looks exactly the same. Now, what does that have anything to do with this? Well, it has to do with this when your boss tells you to do something different. Okay? If your boss tells you and say, oh, guess what? We want to change the way we represent coordinates. Okay? So one day your boss says, this is not a good coordinate system anymore. We want to change the coordinate system to a polar coordinate system, okay, which means you have to express a coordinate with a radius and an angle. Okay? All right? So what do you have to do in both cases? In one case, in the first program, I can keep exactly the same subroutine interface. In other words, when I define the subroutine called init coord xy, I can keep the first parameter, I can keep the second parameter, I can keep the third parameter. The calculation, line 13, is not going to be a simple assignment anymore because I have to use sine. Let me see. So I have to use sine and cosine to do the calculations because I've given the radius to calculate the height and also the width. I have to use sine and cosine. So this will be, this won't be x itself. It will be r times, x will be the cosine of the angle, and then the y will be r times the sine of the angle. Okay. But what about the rest of the program? The rest of the program that you call this subroutine in order to initialize a coordinate. Do they have to be changed? No, because they're using the remote control. Is that making any sense? My so-called dumb subroutine that doesn't seem to do anything is providing a layer of abstraction. Okay? The abstraction is saying the rest of the program is called the consumer. Okay? It is basically, the rest of the program says, I don't really care how a point is represented. I just want this point to represent, from my view, x is here, y here. And that's all I want to do. But inside the subroutine, it will have to do the conversion, because if your data representation has changed from the xy coordinate